Hi, welcome to LensFest. This is going to be a LensFest demo. I'm Len, joined by Jacob.
Thanks, Len. I'm Jacob. I'm going to be helping Len show some visual scripting features today.
And I'm excited to show you visual scripting today. So visual scripting is an awesome new capability to create custom interactivity in like a graphical format. So instead of having to write JavaScript, you can connect nodes together, what you might have seen before from the material editor, and create logic that way. So we're going to do a really simple first example. I'm just going to bring in this little bird to my project. Okay, so I've got my bird in the project. I'm going to have it face the camera. And we want to disable this bird and enable it, just toggling back and forth every time the screen is tapped. So the first thing we need to do is create a script graph. So we add it there from the resources panel and open it up. You'll see it comes with two events to start with, initialize and update event, but we don't need either of those. We can delete them. We're going to add a tapped event. So all the logic in here is going to start from event nodes. These are kind of the root of the action. And this connection here is an execution connection. So this is what to happen in response to that event. So when we get a tapped event, we want something to happen. So if we drag from there, we'll get a filtered list of things we can do in response. So let's set enabled on a scene object. And so now we can see what fields we need to fill in. So we need to know what scene object to change and what enabled state to set it to. So here we can get an input. So scene object input is how you connect to the scene outside of the script. And then for the value, we'll just set it to whatever it isn't currently. So if we get enabled from the scene object, and reverse it, we'll have a value there. So that's all it took. We just took a few nodes in place and we have our script. So now we need to put it in the scene. So the script in the resources panel is going to act on the scene. So we need to find an object to place it onto and drag that script over to add it. And then we can select our object. And now on tap, we can toggle in and out of the bird. So hopefully this easy to create custom logic enables you to add interactivity to your project, even if you weren't comfortable with that before. You can create great designs and great assets like this cute little bird and still easily make it interactable. And if you are already really comfortable with JavaScript, we hope it gives you a chance to organize your projects better, make more reusable pieces, and overall make a cleaner scripting experience. So I'm going to pass it off to Jacob, who's going to show you a more practical example with visual scripting.
Thanks, Len. I'm going to be showing some practical examples of visual scripting. And the first thing we're going to look at is how to modify a material. So the first thing I'm going to do is add an image. So I'll just add an image object here. You can see it pop up on this side. And what we're going to do is make a new material for it. So going to grab a new default image material and apply it to this image. So now we're going to start our script graph. I'm going to name it about change textures. So I'm going to make a new object and just attach this script graph to it so that I have it running in the scene. And now we're ready to start working on it. So the first thing I'm going to do is drag and drop this material right into the script graph. And what's cool about this is that it gives you a direct reference to the material. So now if we do get main pass and then set property, this is actually linked directly to the material, so we can see all of the properties that are built into it. So you can see right now it just has base color, And if I hook this up, it's you can already see it's changing the base color of the image right away. So I can make this red or yellow or whatever we want. But yeah, that's already pretty cool. But what we're gonna do here today is actually set the texture instead of the color. So I just changed the property to base text. So we're gonna be changing that instead. And what we now need is an image to set it to. So what I'm gonna do is add an input for texture. So I'm gonna look up texture input, and just to make sure this is working, I'm gonna hook this up. Yep, I need to grab a texture. So I'm actually gonna bring a few textures into here. Let me see, we have some fun elephant, bird, and cat textures. All right, so now if we go to my script here, I'm just gonna drag the elephant in, and oh, we can see that it's already working. And I'm just gonna rename this to something like texture. So what's really cool about visual scripting is that it's super easy to rearrange the nodes and change what's actually causing things to happen. So instead of doing this on initialize, I'm going to change it to tap event and hook it up there instead. So now it starts out like this, but as soon as I tap, it's going to trigger this and change the texture to this one. So tap, you can see it change the texture right away. We're going to take this a step further though, and instead of just setting it to one texture, we're going to cycle through a bunch of textures. So this is something that a lot of creators want to do, and now we have a really easy way to do it. So the first thing we're going to need is an array input instead of just a texture input. And what this means is that instead of just being a single texture, it's actually an entire list of textures. So you can see here, now we have like a whole list to set. So I'm going to drag in the elephant and the bird and the kitty. So now we have this list of textures in here, but the next thing we need to do is actually go through them. So there's this really great node called the iterator, and what this does is every time you call it, it cycles to the next item in the list. So this is exactly what we want to do here. We'll hook the textures array up to the iterator. We'll make it so every time you tap, it calls the iterator. The iterator is going to call a set property, and we're also going to grab the texture from the iterator. So now every time we tap, it cycles through to the next texture. And one final thing we can do with this is we probably don't want it to start out with this kind of bland default image texture here. So we can hook up initialize, and that will also call the iterator. So it starts out right on the elephant, and we just have to tap and cycle through them. The iterator node is really great because it doesn't just work on textures, it can also work on scene objects or numbers or colors or whatever you want. So it's a really great node, and I suggest you check it out. Now we're going to go back to Len for a look at some more advanced features about writing custom nodes.
All right, thanks, Jacob. Next, I'm going to give another example using some more features of visual scripting. A really powerful feature we think is going to be helpful are custom nodes. So all the nodes we've used so far are built into the graph, but you're actually able to create your own nodes as well. So if we create a script graph, and then if we create, bring in Tween Manager, it's going to now come with quite a few script graph nodes that are meant for use inside of the graph. So I'll bring back our little bird. So this time, let's animate him onto the screen instead of just having him disappear on tap. So on initialize, the first thing we want to do is change his position. So if we go in here, we can see all of the custom nodes available from our project, and we can find tween position from and to. So we'll set up our target object as an input. We can fill that in later once we put this script into the scene. And we just got to set up our positions in the inspector here. So we'll start with it way off the screen and at a reasonable depth from the camera. And let's say animate it up over a second. And then with custom nodes, some of them will also expose extra executions out. So you can see the main one with the arrow here is what to do right after starting this tween. But we don't want to start the next thing until the tween finishes. So we have this onComplete connection that lets us sequence the next tween we want to make after this one. So let's now tween the rotation. So if we connect it to onComplete, and we're going to just rotate it to 0 so that it's facing the camera, and we'll do that again over a second. Let's go ahead and preview those two. So we can find a scene object that we can put this script onto, and we'll fill in the object reference. There he animates up and turns and faces the camera. He's a little small though, so let's make him closer. All right, so we can continue to sequence these together, or we can have him just kind of sit there for a second. So how about on onComplete? We can use a delay here to keep just chaining these sequences together. So that's delayed callback node comes from a library of custom nodes that's just built into Lin Studio. So that one is there and available to us, and as soon as we added it, it was added to our project as another custom node. So on complete, we'll do a delayed callback. Let him sit there and look at us for a second. And then he needs to disappear. So we can tween float. So if you've used the tween system before, there are always tweens of specific things. But here in the script graph, we can just tween an arbitrary number, so tween the float. And we'll tween it from 1 to 0 over a second. And we're going to use that to set a parameter on the material. So we're going to get the material from the bird. It's using just a PBR material here, and we can just drag and drop that directly into the script graph to get a reference to it. So now we have this material, and we want to set a property of it. So we need to get the main pass and set a property. And then the script graph is aware of this material because it was dragged in, and we'll populate this node with all of the properties available on that specific material. And we'll help you understand what type they are and what the options are. So here we want to change the transition to value set up in this material specifically to help us fade out this bird. So on update, we want to set the property. You notice when I connected those, we immediately got a get arguments node, because this on update actually comes with extra data. And so when we connect it, we get this access to the data. And that data is exactly what we want to use to animate our bird. Looks like these are actually backwards. There he goes. He sits there for a second and then fades away. So far I've shown using custom nodes that came in with Tween Manager and were from the library. It's actually really easy to create your own too if you're comfortable with a little bit of JavaScript. So let's create a script. We're going to call this one play animated texture. And I'll add an image component. We don't want this visible immediately, so we'll go ahead and turn it off. So in our play animated texture, we need an input to this node. So using the same input syntax you may have seen used before with normal scripts for Lens Studio, we'll select an image. And then we just script with that image. So we'll get it, and we'll get the material and the main pass. And all these nodes exist where this could be set up in the graph. But sometimes it's nicer to have these reusable simple nodes as one element in the graph so that you don't have to create this sequence of 6 or 7 nodes each time. So this script is just going to get an image component and then play the animated texture that is on it. So now if we go back to our graph, we just drag this in. And we want to do this when this tween completes. So on complete, we want to first enable the scene object that's disabled. We'll take that as input again. Then we want to get the image component off of it. And play that animated texture. And then the last step, we need to fill in that reference that we created input. We hadn't set it yet. So with these custom nodes, you can define any number of inputs and similarly outputs using output syntax. And that includes execution. We can do an output of execution, which is how a lot of those tween nodes were set up. And so this is how you can bring into your project, scripts that were shared with you from collaborators or from any kind of JavaScript reference you find online or any other examples you've seen for Lens Studio in the past. You can just easily bring that code into your project as a custom node and then use it right there in the script graph. And then, or once you've written your own, you can share them with others and start kind of building your own library of custom nodes that you can use from project to project and have more reusable pieces that way. All right, so the next demo, Jacob's going to show you a much bigger project, a really cool lens he built with a spaceship flying around, and show you some of the organizational tools that are available in the script graph to help keep a project of that size manageable.
Thanks, Len. Now I'm going to show a kind of more advanced project that has a bunch of stuff going on in it. So as you can see, this isn't just one single string of nodes. We actually have a bunch of different things going on here. First, I'll show you what the project actually does, which is we have a little spaceship here that you can control with the buttons. It has some velocity, you can turn it, you can apply thrust, and it's pretty much just a fun little spaceship that you can fly around. One of the really cool things about this project is that it uses the UI system that we have on the website. So this is just a really easy way to implement your own UI buttons. And what I'm taking advantage of here is the custom function callback event type in these. So basically, when I go to the buttons, I can set the callback type to custom function, just drag in my my spaceship script component. And then on press, I just type in the name of a function. Then when we go back to the graph, I have execution input nodes. And as long as these match up, the buttons will actually basically call this function and trigger it to happen. So it's a really useful feature in here because I can make it so that when I press this left button, like here, it directly calls on left press in the script and goes into this little behavior. So that's what I'm doing for the left button, right button, and up button, which does thrust. So you can see the on up press here. And the way that these works for anyone who's familiar with scripting is these write to the script.api object. So this is basically the same as saying like script.api.onUpPress equals whatever comes after it. That's basically the function that gets called. Okay, so now I'll dive into the graph and just show us some of the cool organization features we have. First of all, one of the really cool things about script graph is the variable system. You can see up in this top right corner here, we have a list of variables that are included in the script graph. So for each one, we can type a name and give it a type. So I can just add one just to show you right here. Let's make it a string and just call it my cool string. And now whenever I want to, I can either do get variable and choose my cool string and have that a variable available for us, or I can do set variable and choose my cool string and actually change the value to whatever I want. So it's a really cool way to organize your graph and do some kind of complicated stuff. Okay, so we'll get rid of that and let's focus on the graph again. So the first thing I did was actually initialize all those variables. So we have one that just holds the transform for the object, which just makes it more simple to grab the transform later. We have one that initializes the velocity, which is a vec3. And we have another one that initializes this animation timer, which is just a number that we use for animating the thrust. Next we have on update. And so as you might know, this event gets called every frame. So basically every time the screen refreshes, on update gets called. And so what we want to do there is actually the first thing is a sequence node. And sequence nodes are super, super useful. What they basically say is first we're going to execute this line. And then when that's all done, we're going to execute this line. So instead of having to put everything in a huge, long, horizontal line, we can make it more vertical and split things up and just make it easier to use. And it's really great in the sequence node because you can go in and actually change the number of ports in there. So instead of 2, we can have 4. I don't know what it goes up to, but yeah, we can have a lot of nodes in there. So I'm just going to keep it at 2. First, we have apply velocity to position. So this is basically saying every frame, we're going to add velocity and apply it to our current position. A really cool thing going on in here is a subgraph, which if we jump into it, it's a little messy on the inside, but that's kind of the whole point of subgraphs. We're basically taking a ton of nodes and boiling it down into like a really simple idea. So this one is just called move transform. And what it does is it just moves the transform by a certain amount. So I have inputs and outputs in the subgraph. Like you can see execution input, a boolean for delta time, a movement vec3, and a transform. And basically from out here, you don't even have to worry about any of that. You just call this node and it'll take care of everything for you. You can also see here we're using variables. So this is just retrieving the transform and this is just retrieving the velocity. All right, so I'll move on to the next one. This one does some kind of similar stuff. It's basically just decreasing the timer every frame. And we have another cool subgraph here called scale by delta time, where you just pass in a number and it multiplies it by delta time. So pretty simple. But there's another cool thing we have here, a number input, but we actually are doing some cool stuff with input in this case. You can see that we're actually using a group name. So if I go back to the spaceship, I have these inputs grouped into two parts, animation and movement. So this is just like a nice way to organize your inputs the same way you would with a normal script, but you can still do it in script graph too. So even though the graph is pretty easy to go in and change, like you still want it to be nice for another user to come in and mess with it too. We also have another input in here, thrust visual. That's just the scene object, but as long as the group name is the same, which is animation, they'll be grouped together into the same part. Next, I'm going to move on to the button responses. We touched on this earlier. These are basically just called by the button, which then triggers this callback. We go to the sequence node, which we talked about before, and then we just go right into here. We're setting this variable. We're basically just adding the forward velocity, and I want to highlight here the thrust power input. We're doing something cool with this where we have the control type set to slider. So as you can see here, if I just set it to default, it's kind of a boring little number. But if I set it to slider, it lets me set a min and a max, and now I can mess with it here. So if I refresh this, I can start messing with it and making the thrust actually go pretty crazy. And then we do something pretty similar for the rotation too, where we just have a subgraph that rotates around the y-axis. Pretty useful, saves us some space. And we use scale by delta time and also turn speed as a slider as well. One cool thing we're doing here is that we want the left button press and the right button press to actually share the same execution path. So what we're doing is they're both leading into this apply rotation function. But since one wants to go left and one wants to go right, we have this variable that's called temp turn direction. And for the left one, we set that to 1. For the right one, we set that to -1. And then they both go into the same data flow, but they use that variable to multiply which direction it turns. So this is a kind of cool way to instead of like duplicating this whole block of code for both things, you can have them share the same code, but just one variable will be different. So yeah, we have this cool little spaceship now that is very easy to customize, and we could add some more stuff if we wanted pretty easily. But yeah, that's it. Thanks so much for watching our visual scripting demo, and have fun at LensFest.